5 has a 14-pound object, and then a second object moving. A perfectly elastic direct collision. We're given the velocity of the first object after the collision. We want to determine the weight of the second object after the collision. Also the weight before the collision. Okay. Obviously, first thing we're going to do is draw it out so we can keep track of everything. So here's our 14-pound object moving at 7 feet per second. Okay, and our second object moving at -5, and it has a weight unknown. Okay, so this is before, afterwards. Our 14-pound object is moving at a -4 foot per second. Okay, we don't know the weight or the velocity. We'll assume it to be in that direction. We'll call it V2 prime. That's weight of the second object. Okay, so we have two unknowns, the mass and the final velocity of the second object. So we'll need our two equations. The key here, perfectly elastic direct collision, means no energy loss. And we also had an equation that said the relative velocities before was a negative of the relative velocities after. Okay, so there's our second equation. This is basically comes from conservation of energy combined with conservation of momentum. We also had our conservation of momentum, m1 v1 plus m2 v2 and so on. So there's our two equations, conservation of momentum and our relative velocity equation. Alright, so I'm going to write out my conservation of momentum first. We'll just plug it in right here. We use the 14 pounds times 7. We use positive right, plus W2 times -5, and that's feet per second, is equal to 14 pounds times -4 plus W2 V2 prime. So there's our two unknowns. Okay, from this equation we'll move it down here. V1 was 7 minus -5. It's going to be equal to negative V1 prime, that's that guy, -4 minus V2 prime. Lots of negative signs, got to be careful here, but we can solve this equation and get V2. It's going to be equal to, looks like 7 plus 5 is 12. This is a positive 4 on this side, so it's going to be 8. I'm going to double check that. Okay, so V2 is going to be equal to 8 feet per second. Alright, so we made the algebra work out pretty easily here. We can then substitute that in right there and solve for W2. So I'm going to do that in the solver. Okay, so I'll do clear that out. So I'm working with this equation right here, 14 times 7 plus my unknown times minus 5. Move this over to the other side, it's going to make it positive, so plus 14 times 4. Moving this over to the other side is going to be minus my unknown times my value there. Okay. We'll just make a guess of 10 pounds. And it comes out to be 11.8 pounds. Alright, so W2 equals 11.8. Again, it's going to be the same units as all of those. 11.8 pounds. Key to this problem was getting these two equations. This equation right here, representing relative velocities for perfectly elastic, and then this equation right here, conservation of momentum.